So I'm heading out to meet Dean Piper of Muve 3D, DLP 3D printing company based here in Grand Rapids, Michigan. And I left my GoPro mount that I had printed up in the car on my tripod, not thinking about it. This is what happens to the PLA in a hot car all day. So it'll probably still work for holding it in place tonight, but I'll print another one, I guess. Maybe I'll do PETG this time. Yeah, so we're going to talk to Dean Piper. He was the first speaker we had for the My 3D presentation, and he's going to give me a tour of his shop and see what fun toys he's got there. Alright, I'll see you guys in a few.
You can sit down wherever you want
Sure.
to. Sorry. But in the summertime, it really becomes a. How early are you willing to get up now?
Yeah, 4 a.m. sounds good.
Yeah, seriously. I should usually try to be gone by noon, 1 o'clock.
Wow.
At the latest, at least through late June and August.
Right.
Yeah, it's a nightmare. And unfortunately, I was realizing too, I don't have any printers.
That's okay.
I'll have a whole bunch next week.
That's funny.
They're all shipped out. And
Yeah.
I have more to build, so yeah. Yeah.
So it's kind of a build as you go type of a
Yeah, exactly.
print.
Most of our customers will ask for some sort of customization. I mean, it's usually not enough to necessarily warrant waiting on the build, but for the most part, we've just been built to order from the get-go and have stayed that way, just to keep things lean.
Yeah.
And it allows us to start new products more quickly. You know, if we don't have to have a ton of money in stock,
Right.
then
Introduce yourself.
my name is Dean Piper, owner and founder of Muve 3D, based out of Grand Rapids, Michigan. We're here today in the Muve 3D workshop where we do all of our building, assembling, calibrating, and shipping of our 3D printers and accessories. Muve 3D was founded in 2013 by myself. The goal with the start of the company really was to create a machine that people could afford, because I needed a machine and I couldn't afford it. Right. And so I spent a great deal of time doing research and trying to find a machine that would fit my needs. And when I spent time delving into what these machines were comprised of, I was very surprised to find that I was going to be paying well over $10,000 for something that maybe had $2,000 worth of parts in it. And it was very obvious that that's what was going on inside of it. So it's hard to fork out that kind of money when you know that your money is simply going into someone's pocket. Exactly. So I set out to use my 3D printer to make another 3D printer, and to use I guess my time from when I was in the Air Force. I spent a decent amount of time doing network administration and software engineering, but mostly my degree of software engineering, using those things to get around the software hurdles of the needs of a laser printer. And at the time, it was a laser printer that we were really striving to produce. Quorum Labs had just announced a Kickstarter for their machine. It was based on laser galvos, and we didn't really like laser galvos. Anybody that I knew didn't really like laser galvos either. So we wanted to do a Cartesian-based system that was similar to what everyone already knew and loved. So I started designing parts, and once I had a chassis, I went out and started making the software to make that system work as it should. And once we had that, we launched on Indiegogo, and that was the start of the company in March, April 2013.
So you were really ahead of the, well, I guess, that's about the era where Kickstarter and all those sites really took off. Nowadays, it's like, trust these companies on there. Everybody's trying to get on the bottom dollar and just get their wallets back.
Absolutely. I
So
recognize
that was the heyday.
Yeah, it was the heyday, and honestly, even then, there were a lot of projects that had severe fallout. And that fallout, it was disappointing to see. A lot of it seemed to be people unintentionally setting very lofty goals and not realizing the work that it required to bring a product to launch.
Not being able to scale as their
Absolutely. You see success, and you don't put limits on that success, especially early on, and it can shoot you at the door. And that's what a lot of people did. They took in $1 million plus, and they couldn't deliver $1 million plus if they gave them this.
Some of them went out and took joyrides.
Yes.
Next to bought cars.
Yes. And never had to pay that money back, in a lot of cases, and that's disappointing. And that's where we set out to create realistic goals, limit our campaign, and limit the way that we're expanding so that we can do so organically and always be there for the customers that are supporting us. Never leave anyone behind.
What was the scale of your campaign, I guess?
I believe it was a $10,000 campaign just to see if it would work, and we succeeded, I believe, like 15 or 16,000.
Okay.
We did a flexible goal that let us go slightly over, but there were going to be, I believe, ceiling limits of like $20,000 or $25,000 to get started.
Nice.
And we felt, that was enough to get a couple of dozen printers out there. It was going to let us get this space, let us have the website and everything, be what it needed to be an e-commerce platform, and have safe capabilities for purchasing and present ourselves in a professional way.
Nice. That's cool. I didn't know you did that side.
Yeah, I've had to do all of it.
I had heard, I met a guy who had met you. He goes to the GR, Virtual Reality Meetup.
Okay, yeah.
That's his name. Jelly something? Jelly, he goes by Jelly.
I want to say, there's a guy that's like Jelly Box or something.
Anyways, yeah, I met him, and he knew you from GR Makers back then when we were working on it there.
Okay.
So, small world.
It very much is, and it's funny how you see year to year as we grow with the projects that other people are working on, and once in a while we run into folks that are using our stuff and say, wow, this machine's really allowed me to do my thing. And that's really what we wanted to do from the get-go, is enable people to take that next step, take their ideas, prototype, design, and make products that were otherwise out of their reach, or they were just going to have to wait for somebody else to do it and then buy it. And that's not the way the world works anymore, I don't believe.
3D printing is amazing for that.
Absolutely.
Especially with your guys, as opposed to FDM, it allows you to reach into other markets, like potential things that are a little more intricate.
Sure, absolutely. And do that in a way that really brings costs down as well. And then I guess that takes us to the second year of our company when we started with the DLP machines. What actually sparked that, there was a company in Europe that took our tilting build platform design and was unwilling to give us any credit for it. And I reached out to them and I said, hey, this is the firmware that I wrote. I don't see any accreditation, and furthermore, we really saw that stuff on non-commercial attribution licenses. So you can use it as a person, but as a company, you need to ask first.
Right.
And they were unwilling to comply with our request of at least saying something. That's really all we wanted. It wasn't about preventing them from using the work in any way. So I didn't have plans to do a DLP printer, but at that moment I said, if this is the market that we're headed into, then I should probably do a DLP printer as well and see how well we can do it. And within a week was able to convert a laser machine into a dual purpose laser and DLP, and then from that launched the DLP system. And the rest is kind of history. We're on version 2 of the DLP, and while it's not cross-compatible with the laser system anymore, the two machines don't share a lot of the same technological placement in the field. So the laser machine is a little better for laboratory work, medical work, things where you need pulsing and dots in a more controlled manner, where you can also control the depth of the laser, because the laser has a lot of energy in it. Whereas on a DLP system, you have a set grid, and that grid is going to be so big or so small, and you're not going to be able to control depth because the energy is very low.
You're essentially doing it over a larger area, whereas laser is it like focused, kind of back and forth?
It's literally a beam of light, an energy beam of light, where yes, the DLP system is an array of pixels with a large bright bulb, and it's shining that array across. Now, light intensity per any given area is probably similar, but if you get down to the very small sizes, the laser becomes infinitely more powerful than the DLP system. And that works out for folks that are doing, I'm not exactly sure the terminology, but micro vessels. So if they were 3D printing in, say, silicon, they could 3D print an array of pockets in which they could then insert a needle and grow many different types of biological
bacteria, stuff
experiments,
like
yes, inside of those, and they literally have 3D printed a biocompatible platform for themselves to do that in for just $1 or $2, instead of having to order these very expensive ones from companies that produce them for them. So that's where we'll see universities utilizing our laser machines the most. Things like that.
Cool. Oh, let's see. Did you, so you mentioned before 3D printing, did you have an FDM machine before?
Yes.
Yeah.
There's a gentleman here in Michigan, let's say first name Nick, from the Ann Arbor area.
Sure.
When I left the Air Force in 2005, I already had an interest in the RepRap project, and I'd spent a good amount of time looking into it and just trying to see the ways that I could get engaged. But it was very, very early on, and access to components, electronics, things that you needed, it was almost impossible to get these things unless you were willing to go out and have some of it made on your own. Fast forward a little bit to here, left New Jersey back to Grand Rapids, Michigan, and I reached out on a Google forum focused on RepRaps, saying, hey, does anybody have any way that they can help me get started with this? And he reached back and said, yeah, I could probably help you out, and actually came to my house with a set of RepRap Mendel parts and said, here you go, here's your 3D printed parts. And you know, most people were making them out of wood, carving them, doing whatever they had to do to get those parts made. So I cobbled that machine together the best I could. It took, I believe, about 45 days of every single night after work, working until probably 10, 11, 12 midnight.
Tinkering with it.
But you had to learn, you know, I was learning everything that encompassed the firmwares, the software, the hardware, how it all works and what it all meant. And at the end of the day, I managed to print another set of parts that were slightly newer than the set that he had made. And by then, that machine didn't work anymore, and I never got it working again and had to rebuild it. So it was almost a miracle that it ever worked in Alpha. It kind of bootstrapped me into my second machine, which led me into the laser machine. A hand-built machine built the first laser.
I will never complain about my printer again.
I mean,
I take it for granted, but yeah, if you're tinkering with it for 45 days, I would have threw it in the trash by now.
There was no other way to do it. You know, and you had to want it, and it was something that I wanted so bad. It's like, who cares about a 2D printer anymore? I want to make things in 3D.
That's awesome.
Yeah. And it's kind of just been a love-hate ever since. I get frustrated with it, but I love every minute of working with 3D printers and technology. It's something that I would never trade or go back on.
That's how I feel, trying to get mine to work. And they're being a little pains in the asses, but
They can be.
I'm still up there tinkering with it.
Well, I mean, it just shows that there's work to be done, right?
Right,
There's
right.
ways to improve, and when you finally understand why it failed so many times and you overcome that, that usually ends up finding its way back into other people's minds and hands and makes life easier for them too.
For sure.
And 5 years from now, 3D printing is going to be a whole different place once again. I hope we have some amazing, amazing things we're releasing.
Maybe you'll do automation cells. You see Formlabs thing that they put out today?
Yes, I have. Yeah. Those are okay. I think we're more focused on, again, bringing down the cost of very advanced technologies, inkjet or liquid jets, and also LCD. There are a lot of LCD printers coming out, and there are a lot of downsides, a lot of upsides, and we want to try to find the middle ground. We want a user-friendly UV printer, like we have now, not something that's using visible light resins. But we also want to use LCD because it can really shrink the size of the 3D printer. It gets rid of the need for the whole expanded projection area on the bottom of the 3D printer.
Interesting. So you wouldn't need to buy like the aftermarket giant Viewtronics or whatever you projectors. Interesting.
And I can actually show a little bit. Is a rough chassis. There's just a really high power UV light that we have that we're doing some testing with. We're working with different light guides, all kinds of different things to try to make this process work. We've had some success, but the longevity of the LCD panel and the intensity and uniformity of the light have kept us from releasing anything just yet.
Yep.
So underneath here you just have an unguarded LCD panel now. It's a very thin sheet of glass, some Kapton tape holding it to an array of LEDs that you can somewhat see. Probably not with the camera, but
Nice.
that grid is somewhat uniform, but not uniform enough. We're now working with a manufacturer to try to make an array that is directly tailored to our needs. So it would be much smaller surface mount diodes, more densely packed, and then with a light guide that uniformly disperses the light without losing any of the intensity of that light. So even this amount of frosting on this piece of glass here is enough to deaden all of the UV going through. We've tried quite a few different things, some of which we are not willing to share yet.
Yeah.
I'm sure you understand, but yes, we'll have a solution.
Interesting.
We will have a solution eventually. It's not something that we're expecting to have finished overnight, but it is something that when we do release, we expect to have an elegant solution for that is user-friendly, same as our DLP and laser systems now, where if it breaks down on the user, they're not going to have to buy a new 3D printer. We're going to be able to support them and do replacement parts, upgrades in place, all of those things. Right now, the only reason for this big height is we were also testing a 100 watt UV LED.
Yep.
And the heat sink for it is about 6 inches tall, so really the whole system's right here. It's actually really just sandwiched in this little piece right there.
Very low pro.
Yeah. It gets very warm though, so that's part of the other part of the problem that we have to take great care to handle. LCDs cannot get too hot; they will burn.
Cool.
Anyway, I can go back.
Yeah. Man, that's quite a lot. I feel like we talked about a lot. What do you do? I guess let's just change the pace a little bit.
Sure.
What do you do for fun? I mean, you're here tinkering with LED technology, LCDs. What do you do when you're not doing 3D?
Well, besides working on the house, because home ownership has its turmoil.
Right. Just 3D print, more stuff here?
Right, absolutely. No, I actually utilize 3D printing for a lot of hobbies. Lately, I've been 3D printing those EGG electric unicycles.
I'm not sure what that is.
So it's a single-wheeled Segway. You have to balance on it.
Okay.
But you lean forward and it goes forward. You lean back and it goes back.
Interesting.
It's very perilous. The feeling.
Back.
Yeah, you feel a little awkward
kind of like those like hoverboard things a little bit,
Right.
like same concept.
Absolutely, but it's just a narrow 14-inch bicycle tire in the center. You know, most of my projects that I do for fun end up related to work anyway. That's just the way that it is. I think with somebody that runs and owns a business, they find that their entire life is often consumed by it. And even their hobbies in daily life is, in all ways, kind of work. But it's not work. It doesn't feel like work.
It's good.
It's just what I do.
Right.
You know? Yeah. And then there's really no interest to change that. You know, I like seeing the ways that people can utilize technology and the ways that they can utilize something so malleable like 3D printing to just open that box of idea and creation and make something that almost, you know, jaw-dropping sometimes, right?
Didn't exist before.
Yeah. I will say I really do like the 3D printed clocks with all the exposed gears and mechanics. I work on those. And, you know, some of the hobbies that I do related to 3D printing, in addition to that, trying to get into jewelry printing a little bit more. There are a lot of different ways to get to a metal component when it comes to a 3D printed part as its source. Currently you have filaments that are actually metal based that you can just polish, but on the resin side of things there aren't really any of those options. You do have castables, but I've been experimenting with making molds and utilizing art clays that are metal clay to kind of get around the whole casting process. So you 3D print a negative mold, you push the clay into it with just a press, a bench press, and let the clay cure. It's got to harden inside of the part. Now that can take a little bit of time, not being an exposed piece of clay like normal. But afterwards, you can literally hand torch that part and turn it into a metal piece. Wow. I'm getting a little better at getting towards a completed part. I have a few successful objects on the solid side, but on the intricate side of things, I'm still having a little trouble working out the kinks. I think maybe doing it with the torch is not the best idea. There's not enough temperature control, so it's very easy
uneven heating too, probably.
Yes, you know, you want to have everything held together in a nice uniform manner for a period of time so that that metal can fully form and then cool. So it might just be that we need to use a kiln, whether or not we want to, but some experimentation will tell.
Sounds fun.
Yeah.
Blacksmithing.
Yeah. Other than that, I mean, the wife and I like to do things like, you know, get out and hike and bike, snowboard, and we have quite a few pets, so that keeps us happy and busy at home.
Very cool. We'll spend that talking.
Yeah, do so.
So just met with Dean Piper from Muve 3D. As you guys can tell from the interview, learned a lot about his origins, you know, their technology that they're working on and that they've developed. And then off camera, he educated me on all this cryptocurrency that just blew my mind. And this thing, this guy he knows is in Michigan working on CRISPR stuff that blew my mind more. And I'm pretty sure that his company is going to be the start of the robot apocalypse. As soon as the cryptocurrency plethora or something, I don't remember, you internet people know what it is, plethora. As soon as that becomes self-aware and realizes, oh, this guy, he has a 3D printer company, and oh, this other guy he knows is working on CRISPR. That's the end of the world, guys. Yeah, that's all I got. So remember, subscribe, like, and comment. And we'll see you guys in a couple weeks for the Ultimaker meetup on July 25th at GR Makers. And yeah, remember, sign up on meetup.com/Miss3D so we can have an accurate count to know, you know, just how much food we're gonna need, and especially the beer. So happy printing, guys. designing, whatever you guys do with 3D technologies. Have